Okay, today we're going over 6.1. We're going to start talking about quadratic functions. So, it says here, the equation of the quadratic function can be written in the form of this one, y equals ax squared plus bx plus c. We've seen that before, yes? When we were factoring, we had that form, ax squared plus bx plus c. You got to make sure that the a value is not 0. Because if the a value is 0, then this actually becomes linear and it's not quadratic. Okay, so this form, so when it's written like this is called standard form. So let's take a look at each of these examples, and what we're going to do is create a table of values, and we are going to look for the first differences and the second differences, and we're going to graph it and see what they look like. So here, again, we're making a table of values. We've done this before when we were working with linear equations. Here, it says y equals what? X squared. And this is the basic quadratic function. So this is the simplest you can get for quadratic functions. Let's take a look. So how would I calculate the y value here? How would I calculate the y value? What does it say here? What does y equal to? X squared, right? So I take the x value, and all I have to do is square it. So what is the x value that I'm given? -3. So do I write it like this? Is this okay? It is not okay if you write it like this, okay? What did I say? When you are substituting a value into a variable, it's always safe to do what? Draw your brackets. Remember, I said variables are like what? Containers. And there's my container. There's my bracket. So the brackets are my container. And then inside the bracket, I put the x value. So inside it, x is -3, and I square it. So what do I get here? I get 9. And it's actually a positive 9, right? Because negative times negative is positive. All right. So we continue down the column here. And so what do we get here? What should I write here for my next one? -2. Yeah, -2 in brackets. And all has to be what? Squared. Okay, so what do you get here? Equals 4. 4. Yeah. So we get... All right, so we just continue down the column. So it's basically the same thing. Again, we're looking for the y value. The y value is what? X value squared. So that's how I can find the y value. It says that y equals to x squared. So x is -1 here. So -1 squared. And that gives me 1. The next one is 0 squared. Now I didn't put the brackets here because there's no negative sign there. So I don't really need the brackets. So 0 squared is what? 0. Yeah. And then the next one is going to be 1 squared. So 1, excuse me, 1 squared, which is going to give you 1. Okay. Now for positive numbers here, we don't really need the brackets. So we could write it as 2 squared, and that's what? 4, right? But just to, keep it safe, you can just always draw the brackets. Okay. Alrighty. So that's what it is. Now let's take a look. Let's graph this. So we're going to start from the middle. Okay, so I'm going to start graphing from the middle, and I'm going to branch outwards this way, up and down. So where I'm going to start plotting from here. So what is this point right here? 0, 0, right? So 0 on the x. So 0 on the x. Remember, the x-axis is here. The y-axis is here. So go to 0 on the x, 0 on the y. So it's right in the center, the origin. All right, I'm going to go down to 1, 1, the next one. So I go over 1 and up 1. Notice the other one has kind of the same pattern. If you look at the next one up here, it says negative 1, 1. So I go to negative 1 and then 1 up there. Okay. And then next one is 2 and 4. So 2, 4. So we go to 2, 2 over 4 up. Okay. Now I'm going to graph this end on this side here, which says what? Negative 2, 4. So I go to the negative side 2 and then 4 up.
Wait, Mr. Han, why did you circle this way?
All right, so let's continue here. So the last points we're going to do is 3, 9. So 3, 9. And then negative 3, 9. So both, one positive, one negative. So yeah. Now try your best to draw a smooth curve through those points. Okay, so now you see our graph is no longer a straight line. In the other units we were drawing straight lines, and that was called what kind of relation? Linear, right? Because they were straight. In this case, now because we have that x squared, it is actually curving like this. So this curve, right, we call a parabola. Okay, so it's called a parabola. And what kind of shape is it? A U shape, yeah. A U-shaped curve, right? We could say also that it is going to be symmetrical, okay? Sorry? Parabola. P-A-R-A-B-O-L-A. And so someone here mentioned it was mirrored, yes? Yeah, so we can say this is going to be symmetrical. So it's a symmetrical U-shaped curve. Okay? All right. Now, so you see here, we can think of the mirror. It's down right the middle. So I'm just going to draw a dotted line here. So in this case, there's a dotted line right through the middle of the parabola. And that line we called the axis of symmetry. Okay. All right, so again, when you draw a quadratic relation, it's going to be a symmetrical U-shaped curve, and down the middle you're going to have the axis of symmetry. Now, do you remember doing first differences? Why did we use first differences? So we subtracted, but if all the first differences were the same, what kind of relationship do we have? Yeah, we had a linear relation, right? So let's take a look at what happens when we do the first differences here. So when we take these two numbers here, we're going to get, remember, it's the bottom one minus the top one. So it's 4 minus 9, which gives you what? Negative 5. Basically, it dropped, right? It dropped 5. From 9 to 4, there's a drop of 5. So negative 5. And then we kept doing that. So, and then you got 1 minus 4. That gives you negative 3. So now there's a drop of 3. And now you keep going and you go 0 minus 1, gives you -1. Okay, and then 1 minus 0 is 1. Now it's positive, meaning what? It's going up, right? Give me a sec. So 4 minus 1 equals to 3. And then the last one is what? 9 minus 4, which is 5. Okay. So here, the first differences are all different, we notice. So that means that this cannot be a linear relation. So we're just going to say that here. The first differences are not the same. So we conclude, therefore, not linear. All right, so let's see what happens now with the second differences. So we're going to do the second differences, and the way you calculate it is exactly the same as we did with the first differences. You take two numbers and you subtract them. So now we get -3 minus -5. So be careful there, right? So it's a -3 minus -5. And so we actually get +2. And then the next two, we have, what would I write here?
I'm gonna write -1 minus -3.
Very good. So -1 minus -3. And that gives me what? It gives me +2. Okay, so remember, negative and negative make positive. So -1 plus 3 is +2. Okay, let's continue. So this is going to be 1 minus -1. Oops. Minus -1. And that gives me 2. And we're going to continue. It's going to be 3 minus 1, which is 2. And then next one, 5 minus 3, which is 2. Oh, what do you know? What is it? What happened here? They all equal to 2. So now the second differences are all the same. Okay, so here I'm going to say the second differences are the same. Therefore, in this case, because the second differences are the same, we're going to conclude that this is quadratic.
What about that last box?
All right, so let's go to our next example. And our next example says y equals -x squared minus 4. So again, all we're doing is replacing the x with the given x value. So in this case, we start with what? -3 here. So we're going to go y equals -x squared minus 4. So again, we're looking for the y value. And this relation, this function, this equation here, tells me what the y value should be. The y value should always be what? -x squared minus 4. Does that make sense? So you square the x value, you take the negative of it, and then you minus 4, and that's what the y value is going to be. So let's do the calculation here. So what am I going to write? Negative bracket -3 bracket squared minus 4. And you should get an answer there. Does everyone understand what I wrote there? All right, so what does this give you? So -3 squared gives you +9, but there's a negative in front, so that's -9. -9 minus 4 gives you what? -13. Did everyone get that? All right, so what's the next one going to be? I'm going to write -2
minus 4 squared.
Don't forget to square it. Minus 4 equals to. So that's 4 minus 4 minus 4 is 8. negative 8. All right, so let me write the rest. Negative 1, oops, negative 1, negative 1 squared minus 4. Let's give you negative 1, negative 5. So 0 is going to be negative 0 squared minus 4. So that gives you negative 4. And then you're going to get negative 1 squared minus 4. That gives you negative 5. Negative 2 squared minus 4. You should be able to guess what that is. Negative 8. Negative 3 squared minus 4. Guess what that is going to be? Negative 13. Okay, so look, how could I guess that? Because where's the middle? Do you see the middle? Do you see where the middle is? Yeah, the middle is right there, right? How do I know that's the middle? Well, because right beside them, right beside this 1 point here, we see that it's exactly the same numbers, negative 5, negative 5. Got it? So that's the middle, so that means it has to be symmetrical about that point there. So this negative 8, I could have guessed just by looking up here, negative 8 and negative 13. Does that make sense? Yes? All right, so let's just quickly practice the first differences and the second difference once more on this one. So let's calculate the first difference quickly. So here are the first differences. We're going to do, again, the bottom number, subtract the top number. So it's negative 8 minus negative 13. So that gives you 5. Okay, so it went up 5 from negative 13 to negative 8. It went up 5. Here, you got negative 8. Oops, sorry. The bottom, negative 5 minus negative 8. And so from negative 8, you need to go up what? Up 3 to get to negative 5. All right, quickly, let's finish up quickly. Negative 4 minus 5, that is 1. And then here, we're going to get negative 5 minus 4. That's going to give you negative 1. And then you have negative 8 minus 5. That's going to give you negative 3. And then negative 13 minus 8 equals to negative 5. All right, so the differences are what? Different. Therefore what? Not what? Not linear, right? Okay. So now we have to try to see if it's going to be quadratic. So we need to do the what? Second differences, right? So let's find the second differences the same way. So we're going to get 3 minus 5. That's going to give you negative 2. And then 1 minus 3, which gives you also negative 2. And then negative 1 minus 1, that gives you negative 2. Oh, what do you know? Are they all going to be the same? Negative 3 minus 1, that gives you negative 2. And then down here, negative 1 minus 3, that gives you negative 2. Well, what do you know? They're all the same. So same. Therefore, we can conclude that this is what? Quadratic. So I'm going to graph this now. when I graph it, I like to graph from the middle of the parabola. So here we go, 0, -4. So 0, -4 right here. And then you're going to get 1 and -5. Remember, it's symmetrical. So the axis of symmetry is down the middle here because I chose to draw it from this middle, starting from the middle. So that means that across this, yeah? Are you watching? Across this one, you're going to have another dot right there. Does that make sense? So that's mirrored. And then you're going to get 2, let's see, 2 and -8. So that's 2 and -8. And again, right across it, you're going to have another one right there. Now, it's -13 for the next one. That means it's down here. I didn't give you enough room on the graph, but it should be somewhere around here. Okay? And all you have to do is, again, draw a curve around, draw a curve as best as you can through those points, and that's what the parabola looks like. All right, so I'm going to, let's just quickly do the last example here. We'll just do the x and y. We're not going to do the first, second differences, but you can complete it if you like. So let's take a look at this one. You have the x and the y again. Right up here, it tells me that y is always going to equal to what? -2 times the x value squared plus 8x plus 10. So that's what you have to write. You have to write -2 bracket -1 bracket squared plus 8 bracket -1 bracket plus 10. So that's a lot of work. And hopefully you can do that in your head, but if you can't, type it in your calculator, you should get an answer. All right, so I'm gonna write the other ones quickly. So -2 times 0 squared plus 8 times 0 plus 10. Oh, let's just write the answer. The first one is 0, yes? The next one is going to be 10. And then -2 bracket 1 bracket squared plus 8 times 1 plus 10 equals 2. What did you get for this one? 16? Okay. And then we got -2 bracket 2 bracket squared plus 8 bracket 2 plus 10. And that gives you 18. Oh no. I gave you a graph paper that doesn't really fit the this picture very well. All right, so I'm gonna change the graph paper a little bit. Let's change the graph paper a little bit, okay? So this is 16.
Are you doing this in your head or looking at
There's an answer sheet. This one I don't need to look for an answer sheet, right? I should know the answer here. What would the answer be here for this one? I don't need to look, right? I can see the center already. The center is where? Where's the center of this parabola? Huh? Where's the center of it? Right here. That's the center, right? Because you can see right beside it, they have the same number, 16 and 16. So from here, I know that this should be what? This should be 10. And then -2 bracket 5 squared plus 8, 5 plus 10. That will give you 0. Okay, so let me change the graph paper a little bit. I made a mistake. yeah, I didn't give you enough room there. So let's change it so that this is 10. This is 10 and this is 20. All right, so just change it to 10 and 20 here. And then negative 10 and negative 20. And that should help you be able to plot this a little bit better. So again, I'm just going to plot the middle. So it's going to be 2. All right, it's 2 and 18. So 2, 18 is going to be here, right? 2, 18. So each box, I think there's what? 2, 4, 6, 8, 10. Yeah, so each box is 2 going up. So it's 2, 18. And then you got 1. Okay, so 1 and 16. So 1 and 16. So right here. 2, 4, 6. Yeah, so 16. So remember, this is the center. The first one I plotted was the center. That means right in between, right through that point, you're going to have your axis of symmetry. So that means we can mirror that point right here over here. Okay? And then you got 0 and 10. So 0 and 10. And mirror that to be on this side as well. And then, what else do we have? Negative 1 and 0. So, and then you can mirror that one over here as well. Okay, so this is what should look like. All right. So notice that the middle of the parabola doesn't have to be on the x-axis. It could shift around. So, okay, so let's just summarize this. So here it says, describe the shape of the graph of a quadratic function. So we described it already. What was it? Symmetrical, what? U-shaped curve called a what? Parabola. What did you observe about the second differences?
They add up to the same number.
They are
Equivalent.
all the same. Okay. And in summary, we say the graph of a linear function is what? Is a line, and the first differences are constant, right? The graph of the quadratic function is a curve, right? And the second differences are constant. So let's just try these quickly. What would you name them here?
Linear.
So this is linear because it's a straight line.
Neither.
This one is neither.
Quadratic.
Neither. This is quadratic.
Neither.
And this is neither. Now, these neither ones are actually exponential. So just letting you know that these neither ones actually are exponential. Okay, so that's basically it. So by today, you should be able to what? Create a table of values, be able to find the first and second differences, and we should be able to tell if it's quadratic or not. We should also be able to graph the points from the table values and see what the quadratic relation looks like. And yeah, that's basically it. We should be able to tell, whether something is quadratic or linear or neither. All right. Okay, so that's the end of the lesson for today.